talks is more than welcome. I suggest you communicate directly with Klaus, or failing that, you can communicate with me, forther@comcast.net, or through Meetup message. So more than welcome to participate in that way. So without further ado, the March Programming Challenge. Bill, take it away.
Very good, gentlemen. Thank you. For our challenge this week, we had a submittal from Alexander Dumont, and he was not able to make the presentation to be here, but he sent me his material and we've put it onto a slide for your edification. The challenge, as most of you probably know, is to make a change maker, such as you'd find in a supermarket self-service. So the a processor should be able to accept a charge up to $100, accept cash up to $100. If the cash is insufficient, it asks for more money. If the cash is more than sufficient, it gives change. So here was the submitted application. We will see about 4 static slides taken from his presentation. And at the end, we will see a 2-minute live presentation of him scrolling through the entire application in real time. So in this case, we're going to see him pasting the code in the interpreter. He then does a purchase and some additions to the sale. He applies a sales tax of 3%. The user tenders $20. The cash is insufficient. He tenders another $10 and then gets change. So here is the code. Let me expand my screen a little bit so I can see it. So this is a setup. Some variables are declared. You see a couple of the low-level fourth words. And now here are some of the calculations going on to do the total, the balance. And then at this next slide, we see the dispensing of the money, where the change due is then done by modular arithmetic, breaking it down into dimes, nickels, pennies, quarters, bills, and so on. This is the balance calculation that looks for a negative or a plus balance. And then this is an example of the actual transaction, which we'll see expanded in a minute. At the center bottom, the bill of the machine starts out at $15. An additional bill of $16.74 is added, and another addition. So this is the total being built up that the customer's to pay. This is the resolution of it. We see with the little arrows there under sale with a green arrow, the total sale is $76.73. We see the discount applied, the net due, the paid, and then finally the change is broken down, and we see the dollars, the quarters, and the pennies for the change. And here is the live of all that previous code. So he scrolls through the actual code itself. We see all the code details. These are the commands. They're the plus, percent, dash, and so on are 4th RPN commands. Now the billing is being generated. The individual transactions taking place. The money is added together to develop the final total that is due. The money is input on an RPM basis. So you enter a dollar value and then you put in the symbols, either the plus, minus, dash, so on here to initiate the transaction. There's the help command gives you all of the commands that are available. And this is leading up to the final concluding transaction. And this is the final, where you can see highlighted in white is the change that was given. So that concludes Andre's, and I will present mine. We have the same challenge details. In this case, the components that you're going to see is each of these is a fourth word. First, we develop some values, storage variables. We accept user inputs. We then net the user input and the money that's due, determine the change value, determine the change components in dimes, nickels, pennies, quarters, bills, and display the result. This is the overall wrapping program. It's a begin again program, would run indefinitely. We initiate the new transaction, ask for change, process the payment, build the change, show the change, and then finally there's an escape. Hit the escape key to end the infinite loop. These are the storage values. I used a lot of variables on here, or values. I wanted to get this program running as quickly as possible and not worry about doing a lot of stat manipulation. So basically everything goes from value to value. User inputs. This took a little bit of learning on my part, because I had to, on a postfix basis, on a prefix basis, accept floating point numbers. So the key line is, when asking for change for the charge, this is the money that's going to be due. You see the line query, BL word, count to float. Query accepts text until a return. The BL word, count to float, parses out the word and passes it to determine a floating point value, and otherwise ends with an error message. And then finally, when we ask the user for payment, we use the same structure. Processing the payment. In this case, we're determining if enough money has been deposited. So again, it's a begin while loop. We ask for payment, check to see if it's sufficient. If it's not sufficient, we ask for more payment until finally the payment is sufficient, either equal to or larger than the amount that's due. In this case, the values are netted, where we take the money in and the money out to determine, is there an amount due in red, or is there change due, which we see in red. This is the complicated word, which is the parsing. This takes the amount due and then parses it down by division and modular arithmetic to determine the numbers of 20s, 10s, 5s, 1s, quarters, dimes, nickels, and pennies. And this is the display for each of the values. For example, in pennies, there's a pennies if, and then 2 pennies in red. This just displays the a number of pennies and the value represented by them. So this is the part of the report generator that tells the output. In an automated system, those red lines, the 2 pennies, 2 nickels, 2 dimes, that actually be commands that go to the change machine that actually outputs the coins. This is a sample transaction. In red, we see the computer says, please enter the cost. So in this case, the charge is $25.78. And then In green, the user is asked for his payment and he enters 78 cents. The netting process says there's $25 due. So it says, please deposit $25. Prompted to enter payment, he puts in $20. It's netted down to $5 due. Please enter your payment, $5. And it says no change due. This is the same process that's done with a balance due of $37.23. And in this case, the user enters the $20, which gives a charge of $17.23, puts in another $20, and now it is an overpayment. So the change is $2.77, and the output to the change maker is shown as those three entries. Discovery on this. In handling money with floating point, you have to be very careful of round off. And in this case, it's a trace program on the change maker. And notice how it was processing a 2-cent transaction all the way down till the very end. And then there was a round off error. So the 2 cents becomes 1.9999957 cents. So the change maker takes this to be 1 cent due, 1 penny due, not 2. So I had to resolve that in my floating point process. This was a learning process for me, I'll testify. So in summary, I chose the floating point because I wanted to input keyboard with decimal points, and doing that in integer fourth is a bit difficult, more parsing involved, whereas the built-in parsing was available for decimal values using floating point. To get the floating point decimal points to line up, there's a little bit of work to jiggle around leading and trailing blanks. I had to define a division word for the system. And finally, we saw the floating point effects for money, which were a bit of a problem. So overall, we see the problem was straightforward. I was able to develop it in about 2 hours or so. It took maybe 3 hours to polish it up total. And the floating point came into great benefit. So I'll turn back to Kevin. Thanks for your kind attention.
I think Kevin has exited the building, but
Dave is going to take the chair.
Yeah, could you put me out of the general picture, please? I feel kind of exposed.
I
have a comment on that problem. I think what I would have done is I would have had a variable called pennies and a variable called dollars, and not use floating point. Did you think of that, and why did you choose floating point?
Floating point was a quick, cheap, easy way to accept decimal numbers. If I had accepted money with decimals like 20.35, I would have had to parse that letter by number by number by number. And with floating point, I could just do one request for information, get back to the floating point in one step. So I didn't have to parse input characters. But
then it caused you a lot of grief later on. So
exactly, yes, there's grief trade-off. Yes.
Yes. It might have been easier. Do you think, looking back on it, because parsing would be pretty simple?
It's all a matter of taste, said the old lady as she kissed the cow. So, yeah.
Okay, very interesting. Thank you.
I kissed the cow with floating point. However, Andre that did his submittal did his in integer math in fourth integer, and everything was scaled into pennies. So on the other hand, if you look at his material, he does a kind of a ratty job handling decimal points. So anyway, it's all trade-offs. Okay, back to Dave.
I have another entrant if folks will indulge me briefly.
Yes.
Here, let me.
Oh, good. We didn't realize we had more contributions. Very good.
Sorry about that. I think I must have missed the moment to chime in. Let's see. Is that visible?
Yes,
Yes.
yes.
So what I took the pennies route, and so I'm storing the amount owed and the amount paid in pennies, and then I go and print them, as dollars using the regular integer formatting words, and I've got a word to print the status of sort of what's the current charge, and then what's paid, and a way to reset it, and then I've got a word to make change that emits coins, which we'll talk about in a second, based on the difference between the amount paid versus the amount owed, and then you reset things when you make change, and then you determine whether you can make change. What I used as the trigger is I figured this is like one of those vending machines where you the minute you put in a coin, you put in enough money, it immediately emits things. And then I've got a word for charging, that adds to the amount owed, and then a shortcut for that that's just the letter C, and similarly to pay, and then a cancel word that knocks things out. And I'm emitting the status each time in this question make change word so that it shows things throughout. And then to actually do the making of change, I just have a table of the amounts in descending order, and then have a word that for a given amount and a given coin value extracts the using /mod the amount involved, and then prints out that type, a series of them. So it's just kind of the coins coming out, and then the outer word does the dispensing and loops through the different coin types. And so I make the assumption that I can walk all the way down without bound, because you'll eventually hit that one and be able to do arbitrary stuff. And then there's some instructions. So that's the thing in total. And then let me show it running here. Although I got to bring up the other window. Sorry about that. All right, let's try that again. This one. And oops, which one is visible? There we go. So then I'm using the fourth input prompt to take input. And so let's say you've got a charge of 1, 2, 3. It shows the charge, and then if let's say you put in $20 as payment, it assumes that you at that point want to make change and emits the different coins in order, or you can potentially put in several items. Say you put in a 45-cent one, a 67-cent one, and so on. Your charge goes up, and then if you put in only a little bit, you put in a quarter, it assumes you're still putting in money like a vending machine. And then if you stick in a $10 bill, then okay, you've got enough, and it emits the change. And you can, if you put in a charge, and then let's say you put in a quarter, and then you realize, oh, I don't actually want to go through with the transaction, you can hit cancel, and it dispenses the quarter back out to you. So yeah, it went the integer route, but with the slight cheat that I did not deal with the issue of parsing the decimal point, and assumed that input in pennies would be acceptable simplification.
Great, thank you very much. Well, great participation on the challenge. And as we see, there's always design trade-offs between floating point, integer, decimals, no decimals, and parsing. So thank you very much, Brad. Back to Dave.
Okay, everybody. I want to thank everybody for contributing to this month's SVFIG meeting. As Kevin said, Don's presentation on Max Forth robotics will be moved to April. Also, scheduled for April is a presentation by Sam Falvo talking about asynchronous IO in a single tasking fourth related to his fourth box project. So again, that'll be in April. I don't see any other presentations this month. So with that, we should probably, am I correct in that? There's no other presentations? Okay, I'll take that to be, there are no further presentations. So at this time, we should stop the video, Brad, and leave the